Hello everyone, this is Ms. Saturian here, and I'll be sharing some information with you about graphs and trend lines today. Our essential question for the day is, how do we use graphs to show the important trends in our data and to make predictions? We want you to be able to create a graph that includes scaled and labeled axes, accurate data points, and a trend line or curve, because it's a key part in showing your experimental data in science. This is something we will be practicing throughout our first unit and throughout the entire school year. Graphs are one way scientists like to show their data in picture and graphical form. It's a really helpful way to see relationships and trends between two objects. If you were to keep all your data in, let's say, a table, these relationships and trends may be harder to see, so having a good balance between the two are really important. A scatter plot is just one example of these types of graphs, which is shown on the slide, and it is very helpful in presenting a lot of data in an efficient and helpful manner. A scatter plot is a type of graph that has a lot of data points scattered all around, as you can see in this graph. This graph shows a relationship between a student's grade point average and the hours of video games played by a student. If you look closely, you'll notice that there is a direct relationship between the two, with the higher GPA directly linked to lower hours of video games played in a week. Something to think about here for our video game players. In the next few slides, you'll learn how to make a scatter plot step by step. So the first step in making a scatter plot is to identify your variables. These variables are called the dependent and independent variables. Identifying the two can be tricky at times, but the more and more you practice identifying the two, the better you'll get at it. A good hint is that the variable you are measuring is usually the dependent variable, and that time is always the independent variable. The data in this table shows how long it takes for an object to travel a certain distance. Remember, time is always the independent variable, so the distance covered will naturally be the dependent variable. The second step is one you probably have some experience with from your middle school math and science classes. You need to label the x and y axis with the correct variables. This doesn't mean that you simply label the x-axis x and the y-axis y. You'll actually label them with the variables you're using. This step is really important, or else the graph will have no meaning. So the x-axis is always the independent variable, and the y-axis is the dependent variable. So if we're using the data table from the previous slide, our x-axis will be labeled time, and the y-axis will be labeled distance, just like you see on the graph. Make sure you also include the units that you are measuring in, or else there will be confusion on what the data points actually mean. In this table, you'll see that they are labeled seconds for time and meters for distance. While you are labeling the axes, it is also important to have a title as well, so that the person reading the graph can easily understand what relationship they are looking at. In this graph, you are looking at the relationship between distance and time. The third step is to create a scale. These are the numbers you see on the x and y axis. Do you notice that the x-axis is going up by 1 at each mark and the y-axis is going up by 5? This is totally okay. You can treat the two axes completely separately. You have to first look at the range of values in your data set, and you can rewind back to the table in the previous slide to take a peek at it. What are the smallest and largest values on there? So if you go back to the data table, you'll see that for time, the smallest value is 1 and the largest is 5. Usually, your smallest and largest numbers on the graph is a nice round number that is slightly smaller and larger than the range in the data table. So for this graph, we can start at 0 and go to 5 as the scale on the x-axis. And then for the y-axis, our smallest number is 2.2 and our largest is 13.6. So a good range for that could be 0 to 20. Once you've figured out your maximum and minimum numbers, Figure out how large each one of the squares in between will be. Make sure that these numbers are evenly spread apart. So you'll notice that the y-axis goes up by 5 each time, and then the x-axis goes up by 1. Also, a good rule of thumb is that the origin, which is where the x and y-axis meet, is usually 0. All right, we're finally set up to graph our data points. So in math, you're usually used to putting dots down for a data point, but use a small x instead. So the reason for this is that once we put a trend line in, some data points can get covered up by the trend line. Let's go to the next slide so you can see what a trend line actually looks like. Can you guess what the trend line is? This is the dashed line that you see on the graph that is kind of connecting the data points. Now take a look at that line really closely. Is it really connecting the data points perfectly? No, and it really shouldn't. Do not, I repeat, do not play connect the dots here. A trend line, also called a trend curve if the line is curved, is giving you a general idea about the relationship between the data points. Sometimes it won't even go through the data points, and that is okay. Do you notice at the 2 and 4 second data points, the trend line doesn't go perfectly through? Again, totally okay. So trend lines might be a new concept to you, but it is actually the most important part of a scatter plot graph because it helps you make predictions about other variable values without having to collect more data. In this scatter plot we created on the previous slides, we only measured our distance up to 5 seconds, but we could use a trend line to predict the distance at 6 seconds, 10 seconds, or even 50 seconds without having to collect more data. Our time is precious here. The other important piece is that it helps us better see the mathematical relationship between the two variables in the graph. So there are 3 types of scatter plot graphs and relationships that we'll be looking at this year. The first one is a graph that shows no relationship between the two variables. The dead giveaway for this is a graph that has a horizontal trend line. This means that no matter the value of the independent variable, the dependent variable doesn't change. There's really no relationship between the two variables. A good example of this would be, let's say, how many bags of chips you eat and how well you speak Spanish. They simply aren't related. The second type of graph is called a linear graph and relationship. When you think of the word linear, think of the word line. This is just like the graph you've seen in the previous slides. A linear relationship between two variables means that one variable is dependent and directly related to the other. When one variable doubles, so does the other. If it triples, so does the other. So here's the last type of relationship and graph you'll see this year. It's called an inverse relationship and graph, and it looks just like the graph you see to the right. When the independent variable doubles, this does something different. The dependent variable halves. This is like the first graph we saw relating your GPA to the number of hours spent playing video games each week. Again, we'll be finding relationships like all 3 of these this year, and we'll create graphs like these to help better understand our data and the relationships they may have with one another. So to summarize, let's revisit our essential question. How do we use graphs to show the important trends in our data and to make predictions? You can use this question to help you create a summary for your Cornell notes. Thanks for watching.